Welcome back. In this final episode of the initial core concepts of Elyx, we will cover definitions. We have been seeing the white nodes in the canvas, which we call definition nodes, but we haven't explicitly addressed them. These cannot be directly connected to by value or execution connections. Definition nodes are what Elyx uses to let you configure different functionality. They work in the background, like a definition which represents a database. After adding it, your project now has a database. But to interact with it, we always use other nodes, like variables and operations. We never interact in the canvas with the definition nodes directly. A good rule of thumb is that if a functionality runs in the background or is a piece of project configuration, then it is a definition node. On the other hand, if a functionality needs to be explicitly executed, then it is an operation which performs its task only at the moment it gets executed. Elyx knows what kind of built-in functionality a definition represents based on the base functionality that they implement. You can find this in the edit menu of the node, like a database, a table, an endpoint, scheduled execution, external service account connection, and many more. You can change it when editing the node, but we don't recommend doing so because it will likely break all logic that references it. Instead, it is better to create a definition of the type that you need and eventually delete the old one. You can also create a blank definition. This means that Elyx won't attach any built-in functionality, and it acts as a way to define the format of a data structure. This can be useful to, for example, define and interact data structures of a certain format which you don't actually need to store in a database. Like the data sent to an endpoint. We could define what we want that data to look like with a blank definition. We add all the properties to it. Then we could use the validate object structure operation with our definition as its definition to match input, to let Elyx check that our incoming data looks the way we expect it. We can also use it, like the other definitions, as a data type of a variable, in which case we will make the variable have all the relevant inputs and outputs to match its structure. Definitions can optionally be static, meaning that there's only one copy of them, like endpoints. Otherwise they are, by default, non-static, meaning you can have as many entries, each representing one independent copy of that definition as a value. Static definitions cannot have non-static properties, but non-static definitions can still have static properties. The SQL database table is a good example, because every one of its properties will have different values for every copy or entry of the table. But it has a hidden property which determines which parent database it belongs to, which is static, meaning that it has the same value shared across any occurrences of this table as a value. Besides properties, you can sometimes add triggers directly in the definitions. We call this internal triggers. This is often, but not always, restricted for definitions with built-in functionality. But it is always available for blank definitions. An internal trigger can have any logic, just like a custom trigger which stands on its own in the canvas. But the only difference is that it must be executed as an internal call on a variable node which has the definition as its data type, where the variable node is representing a specific copy of the definition. Finally, definitions can often also extend each other. This means that if you have two similar definitions, you don't have to recreate their structure or logic in their triggers from scratch. You can just make the more complex one extend the simpler one, which will make it inherit its structure and functionality. For example, let's say we're building an app for managing our business's administration, which has two definitions representing database tables, a users table and an employees table. Not all users are employees, but all employees are users. With that in mind, given that the user's definition already has a structure that we would like every employee's data entry to also have, we can just make the employee definition extend the user definition. The user definition doesn't change, and it is not aware that anything has happened. But the employee definition now starts by having everything that the user definition has, and it can choose to add more properties or triggers on top, which the user definition won't have. If the user definition changes, the employee definition will automatically change too, to keep in sync with the new structure of the user, which it extends. And that would be all. You're now an Elyx Pro. You have learned every concept in Elyx so that you can build without limits. Time well spent. Not just that, but if you were not a technical user, you have now understood the basic concepts of programming too, which are common to every programming language that software engineers use. Congratulations. Now, go build amazing software at elyx.tech if you haven't already joined. If you need further help, join our Discord server where you can ask questions as you go. Don't forget to like, subscribe, and hit the bell notification icon so YouTube notifies you when Elyx posts more tutorials or announcements.